So our second speaker tonight is Adam Wangrat at Neural Alpha, who I know very well as CEO of Neural Alpha, having worked with him for the last, is it 4 years? Probably feels like longer to you. I would say I taught Adam everything he knows, having worked in the graph space for the last kind of 10 or 15 years. But unfortunately, I think it's probably the other way around. And actually, Adam's kind of taught me quite a lot about graphs over the last 5 years of working together. So big round of applause and warm welcome to Adam.
Thanks, James. Okay, so my name is Adam Wangrat. I'm lead here at Neural Alpha. First, a bit about me. I graduated from King's College London with a master's degree in computer science and artificial intelligence. I've been at Neural Alpha for almost 5 years now, and I've worked on a variety of projects involving data integration, knowledge graphs, spatial data, and AI. A bit about Neural Alpha. We are a sustainable fintech consultancy, and we focus on building bespoke software solutions for banks and asset managers. When it comes to sustainability side, we focus mostly on the E side of ESG, so the environment, and we also often use connected data technologies. Yeah, apart from building bespoke software solutions, we also have expertise in data visualization, developing ESG data strategies, and data engineering, ESG research. So despite being a consultancy, we do have our own product, which is a responsible capital platform, which I'm going to talk about pieces of this platform today. And this platform is a software as a service solution and data product. It's powered by a graph. That's why we are here. And it's a graph storing information about organizations and all sorts of ESG relevant data about these organizations. So like their physical assets. Actually, I'll show you at the next slide. And the most recent addition to this platform is an LLM-based chatbot. That's the other part of the reason why I'm speaking here, which started as a separate thing, and because of that, it currently in production has nothing to do with the graph part. It's answering questions about the company disclosures. So to speed up analysis of companies, so the speed up the manual research that analysts would do while going through hundreds of PDFs to get some answers about I don't know, the company's policies on deforestation, for example, or something like that. So in the graph we have all of these things and like all of these aspects of the data that we store in our ESG graph that is powering this platform, and then there are disclosures are the odd one out because they are just PDFs on S3 and embeddings in vector store, but until now, so what I'm going to talk about, they had nothing. I mean, we still didn't ingest them into the graph, but the bot. I think the point, what I'm trying to say is that the bot was only seeing this, not the whole picture. It was only focusing on the disclosures, and the goal of this exercise that I worked through and I based this presentation on is to enable the bot to query the rest, get the rest of our data. So it's smarter and more helpful. So the current setup is a classic RAG on documents. We have a vector store where we have we chunk the documents, we embed them, store in a vector store, and then when user has a question, we try to retrieve the most relevant chunks and use them to answer the question. And there are some, it's a bit more complicated than that. Sometimes we get back to get more documents. Sometimes we have to redact the answer when we think that maybe it's not based enough in these pieces of documents. Like we make it question itself because it tends to increase the quality. But this is essentially it's a very streamlined process. There is no place for like choosing different data sources, choosing different options. It's just get documents, answer a question. And so we wanted to introduce the rack on graphs into the mix. So it can not only take from the documents but also from the graph. And when I looked at it, the main two options it seemed to me were like direct access, giving it direct access. So if we allow it to read graph schema and give a couple of examples of Cypher queries, it could generate Cypher queries. I think I didn't mention it's a Neo4j graph, but it's a Neo4j graph and we query it in Cypher. It could generate these queries, but that doesn't seem very stable to me. So there's the other approach. I mean, I will get back to it, but the other approach is using a semantic layer. So that's where it doesn't directly access the graph. We defined a set of tools, and which have some Cypher templates, and the LLM calls these tools with arguments and gets the answers. So we have a lot of control over how and when it queries the graph. It seems just much more reasonable because we don't know what queries it could generate. Like, would it be too not optimized enough? Would it run for a long time? Would it actually understand the schema, or would it only generate queries that don't fail but maybe don't make that much sense in real life? So it was a no-brainer for me to go for this semantic layer approach. And how we implemented is we looked at we redefined our bot, because previously it wasn't much of an agent. It was a chain. If you think in terms of like how LangChain calls things, it's like a streamlined process, and we wanted to introduce agency here. So the bot is an agent that has a set of tools at its disposition, and depending on the question, it can choose, oh, I want to query the disclosures, or I want to see what graph says about this or that. I want to choose this of that tool, and then optionally go back and use another tool and another, or maybe use the same tool twice, as long unless it's until it has enough information to generate a response. So I'm going to talk through some of these tools we defined. So first of all, I needed to define a tool to search disclosure documents, because we wanted to replicate in this new approach, replicate what we already have. So this tool is effectively our whole previous pipeline, or our whole previous approach packed into one tool that is only subset of the whole thing does now. It's again a query. It's optimized, embedded, compared with other vectors. We retrieve relevant documents, answer, but this time LLM is triggering this, and the LLM is looking at the results and possibly answering, possibly using other tools together with this one. And as I talk through these tools, I've decided I'm going to show an example that will be like, it will be a continued scenario through presenting all of these tools, and every time I'll show like before and after. And in the first example, it doesn't make that much sense, because before case is no tools, and the bot is instructed not to use any information that don't come from the tools. So I don't expect you to read all of that. I'm going to it's just a proof that it works, and I actually got these answers in the terminal, and you can try to read it, but I'm going to tell you in a second. So before, no tools, no answers, because it's been instructed not to answer. There's no information. No, zero tools means zero information, or is zero information. It's been instructed to use. So after, so in this example, we are asking what are Glencore's policies on human rights, and with this tool, it was able to read disclosures and describe the policies based on a human rights policy PDF or something like that. And that's not that interesting. Let's go to the graph part. So second tool is the first tool where graphs come in. It's the most basic one by far. It's just server query retrieving attributes of the organization node, but I had to talk about it because it's still a rag on graphs. Even though this could be, I suppose, a relational database record or like a document store record, nothing special about it. But with this information now, before, if I ask about their websites, they would say, "Oh, I don't know. I'm just an AI. I don't know the URL. You have to Google it." After introducing this tool, it knew to retrieve the node from the graph, have a look at these attributes, and figure out that the website is glencore.com. Tool number 3, it's probably the most complicated one, is getting news articles by topic. So I don't know if I mentioned that in the graph we have these news articles that are connected to our ESG taxonomy as well as the organizations. So we can query for news related to different ESG concepts and connected to the organization we are interested in. So here I generated embeddings. I use LLM to generate embeddings of all our cost concepts in our ESG taxonomy, and for given topic, this is like just as drawing of this tool. This tool receives a topic, embeds it, compares it with these cost concepts, chooses the most similar one, and looks for news that are connected to it sometimes via like multiple, via longer path of related concepts and to this organization. That's I guess maybe now I should say in all of these tools don't allow the bot to choose the organization we are asking about, because that's how our platform works, that the chat is located at the company profile, so it's predefined what organization you are asking about. So you can even not mention the organization in the question and it will know. So just if in case anyone wondered why I don't mention this part of how do we identify which organization, because we just have organization ID at this point. Yeah, so then we retrieve these news articles with title, text, date, and I'm not sure. There might be more attributes. I don't remember that at the moment, but these are the ones I chose to use in this graphic. And then I like this example, and again, I'm going to tell you what it says. Before, when asked about, I said these human rights policies sound good, but are they actually following them? So it's a continuation of the conversation where I ask about human rights policies, and it defined them based on the disclosures. And it looked at disclosures again and said, oh, based on the disclosures, they basically look fine. They have a lot of make a lot of like promises and have a lot of policies and all of that, and it sounds good. But as it highlights at the end, it would be good to look at third-party audits and news articles, and blah, blah, but it's not able to do that. So adding this third tool made it answer a completely different answer. It looked at news articles because we already know what disclosures say, and it highlighted how in Colombia, communities near Cerrejón coal mine owned by Glencore have reported environmental crises, health issues, and displacement of indigenous and Afro-Colombian Colombian communities, and I'm not going to read the rest, but there is mentions of conflict minerals, child labor, forced labor, and all sort of things that don't sound that good in terms of human rights abuses, and it sums up that clearly there are some issues with the implementation of these policies that sound so good. So the fourth tool is looking at physical assets the organization owns. So for given a list of names of the assets, we retrieve the assets, what the commodities they produce, the assets owned by this organization we are looking at again, or its subsidiaries. I also it will make sense why, but I also included neighbors in this one. It was easy enough to do. We have the coordinates of these assets, so we just retrieved neighboring neighboring mine to this mine we are looking at, or in this example. And in this case, I asked, it meant that news story you just quoted mentioned the Colombian mine. Are there other assets near it that could also contribute to these issues, environmental and social issues that were mentioned? And it just said something like something about ownership of the mine. Then it mentions there is some operation that is near it, and it wasn't very convincing. So I asked, how do you know this operation is near that mine? And it said that according to disclosures, it's in Colombia. So like, okay, it's in Colombia, so it's near. Great. That's not what I was asking about. And when I introduced this final tool, when I asked the same question, it was able to call this tool, retrieve the list of assets matching this Cerrejón coal mine name, and retrieve the 3 facilities that are within a couple of kilometers away, and it knew like who owns them, what do they produce, and I mean, it's just a much more useful answer. And if we wanted, we could ask more about, give me the coordinates of the Papayal coal mine, and then we could maybe look at it on Google Maps or something like that. Okay. Yeah, questions, and maybe I would just final note. Obviously, there's a lot more data points that we would like to make the bot be able to access via this way. There's a lot more node types. There's a lot more in our ESG taxonomy we can utilize this way. So I'm excited to do that next. But this is just and also I have to say that this is in development. It's not in production. The current, if you go to responsiblecapital.io, what you will find is a bot that only answers questions about disclosures for now. But this is what I've been working on recently. And yeah, do we have any questions and answers? Sorry, questions. Do we have any questions? Sorry. So to do what? To do evaluation. Yeah, it is hard. We have some code to do that, but to be honest, we are a bit under resourced, and I wish we could do more of this. Yeah. Yeah, what can I say? It's hard. We also have our like ESG analysts that can look at analyze a lot of questions and example answers, and not example generated answers, and compare with what they would say. We also run experiments with some of our potential clients for this, to not with the graph part because that's very new, but with the documents, and I don't remember exactly. Maybe James remembers, but the Phoenix. No, you don't. So I'm putting him on a spot.
Sorry, what was
Maybe
the question?
Oh, we ran an experiment where the potential client compared the answers based on disclosures of their of our assessment with the assessment their humans their humans did. Their employees did.
Yeah. So I guess, I mean, I guess one of the headline metrics that we've achieved with sort of the kind of LLM and graph combination is at the moment it takes kind of human analysts around 3 to 5 days to do an ESG assessment of a company. So combing through anything from 10 ESG disclosures to potentially hundreds for a listed company. And we're able to get that down to a few hours. And we've done pilots with various companies where the accuracy has been within kind of a 5% tolerance of what a human would generate. So you know, conducting, say, an ESG assessment over a portfolio of dozens of companies that would have been, you know, weeks, if not months worth of work previously in kind of hours or, you know, a couple of days. So, yeah.
Someone in the back.
Yeah, sorry, just probably because it's a follow on for what you just said. So if I understand the way in which this is used is as much as anything, you pose a question and then you let the system go and do its thing. It might take a couple of hours to come up with an answer, or it's an interactive process where the human's in the loop.
So for one organization, it's interactive, it's a chatbot, but we have this batch, what's it called? Because what we call it internally is not what it's called on the platform, but essentially it's a way of asking batch of questions over batch of organizations. So you can define a list, we call it question set of 30 questions. Have your portfolio of 100 organizations, and you run it, and it takes 25 minutes or half an hour, and you come back and you have a table. Like a special thing there that we also have that we don't have in the chat is we allow you to enforce types. So the to ask for Boolean answer, number answer, textual answer, enum answer. So then the resulting table, the columns in the resulting table have specific types. So you can create charts or analyze them in other ways. Then you don't just have a lot of sentences in every cell, and you have to read through all of that to get anything out of it. I think you were first.
Your semantic layer was quite important. Architecture diagram seemed it was sitting behind the agent, right? In the sense, the agent first discriminates that this is going to be a graph query, and then the semantic layer. So my question is, how did you think about the distance function? Like with vector databases, we're using ANN. But here in a graph, you probably wanted to go a few nodes, some sort of depth search as well. So when you were thinking about what are the top k equal to 3 or 5, how did you think about getting that equivalent of whatever the ANN could be to give queries back from the database?
Sorry, top 3 queries. I'm sure maybe this misunderstanding.
Natural language query, and you vectorize it. And then you look at some distance function between that embedding and whatever embeddings you have in your graph database. So
I mean, in these cases where we do it here, now it always happens after the agent already decides what to do. So the question is, in this specific example we're looking at, the question is, what are the Glencore's policies on human rights? And our chatbot or agent or LLM or however we call it looks at this question, and we give it information. You have these 4 tools, and it decides, okay, I want to call this tool with argument human rights. So then this tool, this tool knows is just, I got an input topic human rights. I want to find everything on human, and then it compares embedded human rights with embedded concepts. Okay. Currently, it only presents information, so it's just like a research copilot kind of thing. No, it doesn't can design a portfolio for you based on, oh, I want a sustainable portfolio. So like, that's something that could be interesting to explore in the future. But
yeah, I was just going to ask you a follow-up about the semantic layer, and if you could explain a bit more about how that works. Essentially, you have predefined templates for querying the
Yeah, so these tools are essentially Python functions, and it's we are using for this, at least for this proof of concept. Maybe that's not what we will use in the final version, but we are using LangChain agent and LangChain tools. And why I call this semantic layer, because I've seen it called this way in a couple of places. I know it sounds fancy, and maybe I'm saying something I'm not I didn't intend to say, but I did see it called this way in a couple of places, so that's why.
instead of performing a graph query, you're looking at vector similarity between your embedding and your embedding.
No, no,
No.
no. I define these tools, which are Python functions, and I allowed and I defined what they do, and provided that information to the model in a prompt.
Yeah.
So it's a bit, it will be a bit random. Okay.
It is actually a linked question because semantic layer is what I was thinking as well. So is semantic layer essentially a rules-based engine? So once the 4 tools have been given, some rules have been given as well. Or is the semantic layer, the decisions or the choices are made by the agent without any rules being given? So I was thinking about probabilistic search versus deterministic search in terms of rule-based versus heuristic or whatever is the LLM
It's
understanding.
not rules based.
Rules-based, okay.
It's not rules based.
It's not.
It's not. It's LLM chooses what to use based on the question.
So it is still probabilistic.
Yeah. Yeah. Probabilistic.
Okay. Okay, thank you.
Oh,
Yeah, but,
yeah.
I'm just curious to know, like, is there any thought, is it possible to be able to, from the various sources, to determine what is, so that one very expression, greenwashing versus what is actually reality, and does one article bear more weight than another? How does one evaluate
Yeah,
in terms of, or evaluate how the model has come to an understanding whether something is sustainable, green, or environmental?
It's definitely something we thought about. It's not implemented in any way before because greenwashing wasn't a problem when we only had disclosures. Because what we are saying, we are not saying we give you the truth. We are saying we give you the truth about what the company says, right? So it's we just help you figure out what is this company's position on this or that. So now that we introduce third-party sources, it could be interesting to look into it, because news articles could be good or bad, could be good journalism or greenwashing, and maybe one way to do it is generate some sort of score based on how much of given a news source align with what the company says. If it's 100% aligned, maybe they're greenwashing. Maybe that's one example of but no, it's just the first thing I would maybe try. But we haven't done the work, so I can't say what works. Just guess. Was oh.
Yeah,
All right.
sure. I'm interested in the discovery and development process around the tools. So you mentioned that you have 4 tools. But I'm interested to know if you tried adding other tools, how you've gone and tested if a new tool was actually helping or actually making things worse. I'm interested around that kind of process that you've gone through.
To be honest, it's early days, so it's been just the tools that I've had time to add, and and I have a lot of more ideas, and I guess you can see all these examples that I tried with and without tool, and but you could say it was a cherry picked scenario where it's perfectly with every tool you get a better answer kind of deal, but. Maybe it's not always the case. I think it's too early to say for us. Sorry, I can't be an expert on this and provide you with the answer. Just show and tell, really.
Cool. And I think
That's
we've
it.
run out of time in terms of questions,